Hello, 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 everyone. How's it going? Hello, hi. Welcome to the part three. Or if I may say, welcome back. For the final part of building the mini memory MCP server. Uh, for those who are joining for the very first time, hello, my name is UT. My name is Utkarsh, but I prefer to go by UT. We have been building this mini memory MCP server, which allows us and our AI tools to save memory, like memory in the sense of saving the data. So prompts, results, outputs, anything that we deem to be important for future, we can ask it to save it. Normally you would use markdown files for it, and that is completely fine. But at some point your markdown file grows huge, and then every time you ask your AI tool to basically go and read the instructions in your markdown file, it is too big, and you lose a lot of tokens. So how could we kind of make it such that we could edit it, so that we can read what memory is being saved and if we want to make changes to it, and at the same time we can point it to our AI tools to use the correct memory or only see the relevant memory. Okay, so that is the concept, that is the idea that I was going with. That is something that I'm currently using every day. It's not a new project, there's exist similar projects right now in the market. So there's Serena, which allows you to kind of do exactly the same thing. And then you have Claude Mem, which is for Claude memory saving, saving the memory. Again, most of these run locally, but I was like, how would I build it if I have to? So that's what we have been doing on this stream. The first two streams have been done, of course, and you are in the part three right now. Uh, so I will share the link to this. But for folks who are joining just now, if you could please register for the event, that would be great. Uh, it helps me, helps you, helps MLH, you know. Uh, so please do register. And now here is the link for everything that we have done so far. So we build the RESTful API endpoints, the REST API endpoints for, and we even tested it in Hopscotch. The next bit is to basically build the MCP tools. So we created one MCP tool and we actually saw it in action yesterday, this memory list one, which allows us to retrieve all the memory that has been saved. Okay. So that was what, like, we tried it out yesterday, we saw it in action, and today we will continue building. Uh, we'll continue building and adding more memory tools. Oh, hello, welcome. Okay, yeah. So yesterday we added like one MCP tool, which was to basically just list all the memories, and today we'll like continue building more. Now you may notice that there is slight change here than what was pushed yesterday. Not much. I just went back and I was like, what can we do to improve it? So let me share what I did to kind of improve it. Nothing major has changed. We still have the compress rules. Oh, for folks who are joining today, compression rules. So the idea came from the caveman language, which is the newest and hottest thing out there, which is about kind of making your AI agents talk in a caveman language so that it uses less tokens. We discussed a lot about how token is equal to money, right? So we want to minimize the amount of tokens but maximize the amount of output that gets generated, right? So this, like, there's a whole skill that you can add in Claude and I guess everything else. But at the same time, I was like, if we have to do it manually, and and also not add the skill, but have our own slight kind of like a rule, what would that look like? So this is what we created, like the compress rules. So this was the before, this is the after. Nothing much has changed other than instead of being a concatenated string, it is now an array. uh, The instruction has become a bit more explicit around like dropping articles, fillers, pleasantries. uh, it has some ideas like about how to compress. So example, use fragments and short synonyms like fix, not implement, a solution for. Like that's too big. uh, Similarly, the symbols here, abbreviations have slightly increased, and the limits that we also said, like keep under 100 words per memory. But I have added one more thing, which was preserve all technical terms, code paths, and URLs exactly. Because if you compress the URL, then you will be in slightly bigger trouble, right? Because you like then you're pointing to the wrong URL technically. So we don't want to compress the URLs, but everything else, like whatever is the filler words that can be compressed, that is what this compress rule is about. Of course, you can enhance it, you can add a bit more symbols, a bit more abbreviations, uh, just so that whenever you are saving the memory, anyway, in cloud memory, in your memory, that in your database memory, which is in like the local database running here, so anyway you want to use minimal so that when it reads that memory, it understands the context but it spends less tokens. So that is here. The second one is this spacing issue here and there, but this description is currently like just to follow the pattern for other ones that we are going to write down. I made this kind of um, I'm using backticks for string concatenation in JavaScript. That's it. uh, Tags and everything are there. The description, I try to make the description more precise, because these descriptions are like, sorry, this description is read by the AI tools. This is for the schema uh, that goes as an input. So just try to make that a bit more concise, a bit more precise, and that's it. So I guess I'll push this out so that you all can take a look at it, take a look at the latest commit, and then we'll add a few more tools. The So ideally we have to add, we have just done the list memories, but we have search memory tools, delete memory, update memory, get memory, and create memory. So we'll try all of this. We'll add MCP, which can be accessed by Copilot as well. So currently it is not. We have to add that. We will add I'll try to add a claude.md as well as copilot instructions.md, which can act as instructions for the AI tools. So, every time something starts up, Claude reads claude.md, and claude.md, we can tell it to point to mini memory MCP server to read the memories. Okay, so list all memories, something like that. So this would be kind of refactor. Okay, you should have the latest now. So if I Oh, someone raised a pull request. I have not looked at it yet. Okay, thank you. I will merge this possibly. Going back, yeah, there you go. That is the latest commit, which will have changes. So do keep an eye on it. And now let's continue. Any questions, anyone, before we go ahead? Okay, no questions. Let's move on. Uh, for folks, like Anyone who thinks like this is going out, like if you're not understanding this, my sincere suggestion would be to like watch the part one and part two, because we covered a lot of ground in part one and part two. So part three, the focus would be on just adding these MCP tools, and then we'll move to the UI bit. The UI bit would be more of copy paste, because even I did not write most of it. Yes, you can. You can watch it on the YouTube channel of Major League Hacking. Let me just share that. There you go. So you can find all the previous streams, not just mine, everyone's. Uh, like from like I don't know, way years ago. So uh, yeah, you can find them all on the Major League Hacking YouTube channel. Okay, so as I was saying, that if you are thinking that I have like, if this is not making sense basically, then my sincerest suggestion would be to go back and watch the previous streams, uh, because that's where we covered a lot of ground around these tools, and all the discussions that we have had, some really good discussions, I would say. Then come back and watch the stream 3. You can stay around if you know about what I'm talking about. That would be great as well. uh, and if you think that this is a beginner level, please still stick around and help others who don't. That would be really great. And finally, oh yeah, I was talking about the UI bits as well. So the UI bit is more of a copy paste kind of, because even I did not write most of it. When I started writing, Copilot was helpful as usual. So it created, and in bits and pieces, I just asked Copilot to create, like, let's say a card. I guess I wasn't bothered about creating how a card looks like. Uh, so yeah, we'll be mostly doing some copy pastes here and there. Yeah, I guess that's it. Okay, so listing all memories, this is good. This is a good start. Next one that we want to focus on is going to be create memory, right? Hmm. So we will do server dot register tool. Then we need to give it a name. Memory create sounds good. And then description and something something. Okay, perfect. But slightly different here. Okay, so in terms of description, okay, so in terms of description, we need to improve this, because this is the one that will be given to uh, your AI tool. Okay, so this description is for the AI tools to understand. So create a new persistent memory, blah blah blah. Okay, create a new persistent memory before calling. Let me give an explicit instruction. Before calling, check memory underscore list to avoid duplicates. Okay, update existing memories instead of creating new ones. New ones. And then content should be compressed using the following rules before saving. Yep, this sounds like perfect detail. Now, okay, yeah, I'm still pending around. Okay, let's go to the next bit. I can remove this. So step one, what is going to be the title of the memory? So we are passing the title. It would be a string, and it would be, and we need a description. So short descriptive title, 3 to 8 words should be fine, right? Use as a scannable label. Okay, easy to scan through and quickly understand what the content would be based on the title. So title, next is going to be content. So it would be a string as well, for us. And in the description, let's see, I think I can write it slightly better in terms of, this is the memory body in compressed shorthand. Okay, and we can say that C tool description for rules, max 100 words. That goes back to our limits that we have said, that this can only be max 100 words. Then we'll have the tags. So tags would be an array of strings. We know that it will be optional. And now going back to the description, I think again can write it better. Categorization tags using namespace colon value format. Example, languages, type bug, status open, more like project, let's say, my app. Okay, uh, could be a lang, which could be ts. So short form, shorthands, making it easier. Or in this case, actually tags could be big, right? TypeScript, yep. Use liberally to enable later retrieval via filters. Ah, no, I don't want this yet. What is it used for? Used for filtering memories in memory list. Perfect. So this is a better description. Okay, and mm, that's the end of our input schema. That's the end of this whole description bit. And now what happens? Okay, what's the API call going to do? So the API call, asynchronous API call, title, content, and tags will be provided. Uh, create memory with, okay, slightly wrong. I'll call this as memory, and we will call, oops, what am I writing? Create memory, but create memory takes them not as like individual things, but more like comma separated values. Okay, three props, not destructured. And the return would be content. It would be type text as const, and the text itself is going to be JSON dot stringify the memory. Okay, so this is the content that will be saved. Okay, stringified version of it completely. Okay, so I guess that is our second tool for memory create. And now let's go to the next one, memory read. Yeah, get memory. Let me call it read memory. Memory read. Uh, let me use exactly what I had written before, so that we can spare some time around it. So this is what I had before for memory read. So let's go through it. The name of the tool in the MCP list would be memory read. What it will do, it is supposed to retrieve the full content of a single memory by ID. Okay. Only when used when you need to complete the text of a specific memory after seeing its summary in memory list or memory search. And then we have the input schema and what is it going to uh, what endpoint it is going to call, what REST API call it is going to do, kind of. Okay, so we are saying that the memory is going to call the get memory. Now inside get memory, we have done uh, some catch situations. Okay, so we have ensured that if, let's say, something is not right, something is not found, then we return an appropriate response value back. uh, in this case, I'm also doing it here. So if this they did not find a memory of this ID, then it should show this text not found, and is there an error true. So this will then tell the AI tool that there was an error and the memory was not found, and then the AI tool can give us an appropriate response. uh, if it is found, then we follow the same pattern as others. uh, Next one would be, let's say, update memory. Okay, so, well, very simply, I'll follow the pattern, just copy pasting that, everything that I've already created. So memory update, uh, that is going to be the tool name. The description is right here. Then the input schema, what you want to update, and the things that you want to update, right? So if you want to update the title, content, tags, all of those here, then the API call, if it did not find the memory to update, so of course in that case it will throw an error. If it did find the memory to update, then it sends this one out. Okay, uh, then we have the delete memory. Okay, once again, so memory update in existing memory, only provide fields that changed. Omitted fields stay the same. And memory delete is for permanently delete a memory by ID. Only when memory is irrelevant or fully superseded. For corrections or refinements, use memory update instead. Okay, so that is important. Uh, we are basically giving our AI tool instructions of when to use them. Like if, let's say, it tries to call memory delete, and it's only to, let's say, update a memory and add a new one. In that case, if the memory already exists, go and yeah, use the memory update tool instead of just deleting it permanently. And finally, I think we had search memories as well. Yeah, this is the last one. No, we don't need this type memory. Not used. Won't be used technically. Hmm. For search memories, it will be for, like, it will use the FTS5 that we saw yesterday. It will be used to retrieve specific memory or specific details of a memory. It will also have the negation involved. So if the user is saying that minus of something, like minus global hack week, so then return all the memories without the word global hack week there. So let's go for that. Here we go. Here's the search to here's the tool, the description, the input schema, everything else. Perfect. So again, description talks about SQLite FTS5, quoted phrases, negations, results ranked by relevance, search query, what it will look like, kind of, and which function it needs to call, and what would be the return. So that's all of our memory tools, MCP tools. Should I push it right now? Let's wait to push. Let's create the VS Code mcp.json as well, so that we can see that in action with these new tools. Okay, so if you want to add a MCP server in VS Code, let me come back on screen. Yeah, if you want to add a MCP server in VS Code so that your Copilot can use it, the easiest way, or the way, is mcp.vs code folder should be created. In here, you have to create a mcp.json file. So this is a special file where it tells like where you can add different, like multiple mcps, okay, multiple mcps. So the mcp that we want to add, so oops, the one that we want to add is going to be in the servers bit. And then there we go, there are two servers. That's there are two suggested ones. I don't want this, or more like what I want to improve here. So here my mcp will be called as mini dash memory. The instead of command, it would be, actually command would be npx. And we need a type as well. Type would be standard IO, so that it directly connects to it. The arguments are going to be tsx. Then we need to give it the file path. So let me just copy paste this file path, and then slash server slash index.ts. Then finally, the third argument would be dash dash standard IO. And we don't need the environment or anything. So this is the mcp.json. And as you can see, there's already this start button and there is this more button. One other place to find it is if you go into this currently, and if I yeah, if you go into this configure tools, you can see some of the built-in mcps that already exist in my system. The mini memory mcp is currently unchecked. Okay, so let me hit the start button. Says running, no errors. Let's go back here, and there we go. All the mini memory mcp tools that we created are now here. Okay, you can stop it, you can restart it. It has 6 tools. uh, yeah, I guess that's majorly it. Configuration, you'll come back here. The output, it, if you click on it, it will show you the output where it like connected it from. It is running, it discovered 6 tools. So now we can ask it to use those tools. So let's do that. Okay, um, let's ask it to create create a persistent memory. What did I name it here? Mini memory mcp. So actually, let me just to follow it along, just to ensure that it follows the same pattern, let me rename it. And well, then now it's going to throw an error, of course. We'll need to start it again. Okay, create a persistent memory using mini memory with details of this project. Let's see what it turns up with. Okay, so ideally it should see which tool to select, which mcp tool. It goes for the memory list one first. So it says that this is what it is going to call, and that is fine. I think I can allow it to run in this session. So step one, it first always lists what are the uh, existing memory that exist. Okay, and now it is reading the whole project. Okay, fine. This is good. This is good. And now it is going to run a query. Okay, it's searching through my data, the already saved data. It is now setting up, and it is now going to go for the memory create MCP. Okay, the memory create tool. Sorry, it is going to have this title, this content, and okay, this is good. Okay, so it has successfully created one. Let's go and check. I'll need to run my server. What was the command again? Start. So on port 5172. There we go. 5172. Oh, that's how's that running? Anyways, 5172. There we go. It has created one memory, mini memory MCP project. It is 20 repos, standard IO, storage, SQLite. Okay, this is good. Can we do a word count on this quickly? Word counter. 66 words. Pretty cool. Right? Pretty cool. Around like in 66 words, it has been able to add all the details. And as you can see, it is following everything, the every compressed command that we had given it. Okay. Uh, it's using at the rate for at. It is using short forms like core operations is now core ops. Da, 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 da. Okay, cool. And this was the initial one that we had created manually using hopscotch, and this is the latest one. Okay, any questions, anyone? The same could be added to like a Claude. We saw that yesterday, so I'm not adding it today. But yeah, there we go. Our MCP is technically ready in a way. Okay. Thank you. Uh, okay, so the next bit that I think we should do before we go ahead is adding two files. One is claude.md that I will add, and for VS Code, you have to create .github folder, and in here you have to do copilot instructions, right? Copilot instructions.md in Visual Studio Code. So in here, in the .github folder, we have to create copilot instructions.md. Okay, so let's create this file. So this is our copilot instructions, and we'll also do the Claude instructions. So what instructions do we want to give? So we need to tell it that, let's start with like, let's say title of this. So mini memory MCP. This project uses a local persistent memory server. Follow these rules in every session. Startup, always do this first. Okay. What it needs to do is it needs to call memory underscore list at the start of every session to get a list of all memories. Start of every session before doing any work. This loads all saved context, preferences, and decisions. DECISIONS, decisions. Okay, so now this is a startup command. Technically, uh, we can give it some details about saving, updating, searching, and deleting memories. Use memory create, memory update, memory search, and memory delete to manage memories. Always use these tools instead of trying to manage memory yourself. Okay, this is, I think, good enough description. Uh, and the description of these tools are already written in the MCP description itself. So I'm not going to repeat this. And token efficiency. Okay, I'm going to say that memories are stored in compressed shorthand. When reading memories back, interpret interpret abbreviations naturally. Natural, naturally. Yes, naturally. Do not expand them in your responses unless asked. Okay, so I don't want it to read short and memory and then expand it, and that then I'll end up with more token usage. So I don't want to do that. uh, and I can just copy paste this exactly in Copilot instructions as well, and that's it. So now this instruction should be applied to any of our agents, any new agent that we create, not agent, sorry, any new AI tools that we use, anything that we run, anything that we use. uh, okay, all of them should follow these instructions. I don't know what to create for Codex. I've not used Codex or Cursor, sorry. So if anyone knows in the chat, please do let me know, like what kind of file do you need to create as instructions. I know for Claude you have to go for claude.md, and for Copilot this is the one. The others I've not used it. I can of course Google search them, but if anyone knows or is using, like what should be initial instructions. Agents.md, isn't that for the agents? Is that for Claude or something else? Okay, so I guess this is good enough point to basically push this out. Okay. Do I have anything else here? Nope. I guess this is good. So now this applies to every. You can ask it to use this MCP. You can ask your AI agent to use this MCP every time. If you add these lines in your any project, wherever you create Claude.md, any project, if you add this Claude.md directly there, yeah, in that case, uh, for that project, it will use the MCP to uh, save, the memory, and you don't have to run this or anything locally unless you want to see the UI, uh, because we have told it to use the direct path, okay, to the file. So as long as you don't change where the folder exists, uh, it should be working fine just as is without any changes or any errors whatsoever. Okay, good. Let me just push this. So git add all, git commit. We did so an additional feature added more tools, and now mcp.json, this will be hidden. So let me add this in readme. What is auto gpt? What? Connect the mcp server via standard IO with Copilot in VS Code. Is this Bash? In your VS Code slash mcp.json, okay, this is what you have to do. Is this instruction enough, or should I just write like create a .vs codes folder and create a mcp.json file? I think this should be enough. AI can interpret this, so you know, not like JSON, right? Yeah, perfect. I was like, but JSON doesn't have comments. Ah, annoying. Okay. I think this should be good enough. Anything else that I'm missing? Oh, Claude spelling. And this should not be this. This should be path 2, absolute path 2. Okay. So let me just do an add on this as well. Added more MCP tools and instructions for Claude and Copilot. And push. Now you should have instructions, MCP tools, readme updated. Perfect. Awesome. There we go. So here it is for everyone. Oh, okay. I didn't know that. This is pretty cool. I will check this out afterwards. Uh, Maybe you can add it to your pull request as one of the reference URLs. Agents.md. Awesome. So here you go. This has all the details that you would need to basically run the MCP. Uh, ooh, it has increased to 9 stars. Ah, awesome. Thank you so much. Quite like it. Like, boosts my ego. Yep. Thank you so much to you. Uh, okay, cool. So that's all our server side work. I don't think there should be anything else in terms of server side. Uh, as you can see, it automatically creates this data folder if it didn't exist. I did not create it. You remember we writing code for it, but it has created that. It has created this SQL file, SQLite file, which is not readable. It has created this write ahead uh, and I have no idea. Like two of these files, I have no idea what they do. The while I know the SHM, I don't know. Okay, now let's go to the UI bit. Let's make a UI. As I said, like from the UI perspective, there won't be much to do. Currently, our UI. Oh, one thing that we forgot, right? Oops, is what if you don't want to run it like you don't want to do a standard IO connection? What if you want to do the HTTP connection? Okay, in that case, how would you work it out? So let's do that change after we have completed uh, after we have completed the UI. That would be better. Okay. So we had a section yesterday, if you remember. We had the if and else condition around if standard IO, this is what you need to do, else this is what we need to do. But this wasn't really completed. So possibly uh, that is what we can come back to. Okay. Adding to it, improving it. Okay. So let's go into the UI folder. So I'll just cd into the UI folder and npm run dev 5173. There we go. Mini memory MCP running, up and running. Very simple. There's nothing there right now. Uh, Files that we would need to create. App.tsx exists. That is fine. We will need API.ts. This is where all the API connections would go. I had created a hooks folder with one file called as use memories.ts. And other than that, I had created a bunch of components. Memory card.tsx. Not a memory card, but more like a card, a UI card of memory. Uh, Memory form.tsx. This is where you can actually kind of create memory by yourself on the UI on the web. Memory list.tsx, listing all the memories, and of course we'll need a search bar.tsx. All the CSS has already been copied. Main.tsx doesn't need changing. So we will start by let's start from api.ts. That's easiest. Okay. We'll have Copilot helping us all the way. So what we need is what is the memory? What does a memory look like? So I am sure we had created the type yesterday. Yeah, there we go. So this is what I'm going to start. Like a memory that will be received or created on the UI will have ID, title, content, tags would be string array, created and updated at. Okay. Uh, then we need to define the base path. It's going to be /API/memories. Then we will need to handle the response. Okay. The name is going to be handle response. I'm going to keep it generic. Like you can keep it generic. You can tell it that it needs to be of a certain type, that the response would be of certain type. What would be ideal? Let's keep it generic. Okay. So I'm going to say it is of type T, where T could be technically anything. Then we'll have the response, which will be of type response, and returns a promise, which is again of a generic type. Okay. So generic type means it could be anything technically. Okay. So if not res dot okay, we are not receiving an okay response which is in the lines of 200s. In that case, we will say const error equals await rest dot json dot catch. And I have an error. Let's do an error. What else? I'm thinking, and we can just throw this error. Hmm, just throwing the error out. If the status is 204, in that case, we can say that there is no content. Uh, I'll return undefined because null is technically a proper value. Undefined means it is not defined. And we just as t. And finally, when everything goes successful, we can return rest.json as promised t. Okay. So this is just us creating a generic wrapper around all sorts of request that we are going to do after this. Okay, so we'll use this handle response for any kind of response after this. So example, if we call list memories, okay, we are going to make a request to an API endpoint that is going to return us a response, and in that response it can either be like an error, or it could be, let's say, 204. uh, if it's neither of these, then we just return the whole response as a JSON. Okay. So this is kind of just a wrapper function around it. You can enhance this a bit more. You can be like, oh, uh, I want to handle maybe one more code. Example, I don't know, 404. If 404 is returned, in that case, don't show something or throw a new error of not found. So you can do pretty much whatever you want to in here. Uh, what else? I guess that's it. Next one is going to be create memory. Okay, so we'll from the memory we will take, yep, all of this and promise perfect, and fetch base path. This is good. Content type, yes, this is good. Method is also fine. Body would be stringified memory.json and return. Hmm, okay, so this is good. We will, like, we could technically take this handle response here as well, but that's fine. So what we have done, this function create memory, it is going to from the memory, it is going to omit out ID created at and updated at. Okay, why? Because this would be uniquely generated. This would be done on the server side when the memory gets created. This would be done on the server side every time the memory gets updated. Okay, so basically, if we omit out everything else, what we are left with is the three things, which is the title, the content, the tags. So we are sending that out as a stringified JSON. Mm, and we are using a fetch directly. So we are not using Axios or any other wrapper library, just using fetch directly. And now handle response, we can say that the type is of type memory. Okay, because this could take a generic. So as you can see, when there was no type defined here, okay, it still technically understands based on the input, but we can be explicit. So this T, if this is the first time you come across T, it is nothing but saying that whatever is the input that the user gives me, everything will follow that particular type. So the response will be of promise of whatever type the user has given me. The input will be of the type the user has given me, and both of these need to conform to the same type. So now the input is of type memory, and the response will be of a promise of type memory. Okay, which means that the response object will conform to this. So that's a create memory. Uh, then we need one for list memories. Okay, so I'm going to do export async function list memories. Now that can take a search result, which was optional. That would be a string and a string array. This is good. And what are the parameters? So in the URL params, we will have if search is provided. In that case, append to the search. Okay. If tags is provided, then for each of them, append. Uh, okay. I would have gone for like if tags dot length. In that case, append tags to tags dot join. Okay, so this is basically going to create example search request would be, yes, something like this. Yeah, so this is what we will send it as. Cool. Let me also add something here as well. Why does it always do? I'm not doing a single retrieve. This is a creates a new memory. Hmm, okay, and we can actually wrap this in backticks for it to be more of this particular format. Maybe here. Okay, perfect. Uh, okay, so I didn't read what it wrote here. So it's saying that a response is going to be await fetch the base path, fine. Params dot toString, that is fine. And the response will be a memory array. Mhm. Okay, cool. Uh, so we have list memories, we have create memory, we should have update and delete, two more functions. Again, come on. um, we need to create. Hmm, okay, so update memory will take an ID. It will take the updates. I can call it data. Like it's a partial, and it is going to omit out the ID created and updated at and everything else that could potentially be given to it. The problem with this is, okay, not the problem. Because of the partial, everything becomes optional. So currently, since these don't have question marks, these are compulsory. Okay, but if uh, in update memory we know that things can be optional, so that is why it is wrapped in a partial. So it makes all the properties optional. Okay, so update memory we will not patch. We'll go for put because that's what I wrote on the backend, right? uh, Okay, perfect. So now this would be again of type memory. Perfect. And finally, delete a memory by ID. And in this case, we will do okay, string fetch base path and awesome. Okay. Do we need this? Nah. We'll do this filtering already on the JavaScript side. So I guess this is our basic APIs. This is a wrapper for all kinds of responses that could be returned. This is these are all the APIs that would talk to the RESTful APIs on the server side. Uh, Instead of patch, I used put here because in the server side, I remember writing put in routes. Yeah. Okay. And yeah, I guess that's it. Cool. Let's go for the next file. So the next file that is going to be important is going to be the use memories hook. Okay. So use memories hook. This is going to manage any sort of searching results, debouncing, filtering. It's going to do a lot of things. Okay. So without wasting your time, let's see how much time do I have. It's 12:02. Okay, let's write this one down, but the others I can kind of copy paste, right? I don't need to spend too much time there. So going to create export function hooks, not a placeholder. So by the way, quick question, folks. What's the difference between using a normal function versus using a hook? Like from your perspective, okay, what is the difference between using a hook versus using a normal function? Let me see if any responses. Oh, I missed this question. Thank you so much for answering. Yeah, we're building a UI for viewing the saved memories and also for creating our own, okay, manually creating memories that will be then used by our MCP servers. So we can create multiple memories, we can delete memories, we can update memories via the UI as well. Okay. Uh, as you can see, I'm creating a lot of state variables. Mhm. Mm. Okay, cool. Uh, Hooks is easier to call. Mm, I mean, functions are technically easier always. So the difference between a pure function and a hook is around managing data. okay, and using the React hooks. So you cannot call use state inside a pure function. Okay. So example, if this was called as memories and the file was also like memories.ts, then this will complain, or like even just renaming this from use memories to memories, this starts complaining even though it is imported. The complaint is that you are calling a hook inside a pure, like inside a function, okay, and that is not allowed. The rule of hook says that you can call a hook only inside a hook, and there you go, it's gone. Okay, so adding that word use makes it a hook, and that is like one of the not the minor but the initial understanding of a pure function does not allow you to use the inbuilt React hooks. You have to create a custom hook, which is nothing but a wrapper uh, around like other hooks that you want to use. The second most important thing why you would use a hook rather than a pure function is that a hook can help you manage state. Okay. A hook can help you manage state by using, let's say, use state variables inside, or you using use ref inside, or you can call use effect to kind of rerun something. So a hook will allow you to manage state. Functions are supposed to be pure. Given one input, it gives you one output, and that's it. Every time you give the same input, it should give you the same output, nothing else, nothing more, nothing less. So the difference between hooks and pure functions is, one, allowing you to use React custom React hooks that are available, and secondly is to manage state. Okay, so now to manage state, you can have the same hook between two different components, and one component, let's say, update some value, the other component can read that value and update itself. The second component can write to that, and this first component can read that and update. So it is reactive as well from that perspective. Okay, a function will not do that because it is not going to save any sort of state, it is not going to remember. Okay. Oh, awesome. So yeah, that is the difference between hooks and pure functions, like one of a popular React interview questions, I would say. Sometimes, right? Okay, next is Hmm. Okay. So fetching the memories, I'm going to tell it to kind of what I wrote the function already. So go and fetch all the memories on the, think of it as either the first load or anytime you want to fetch memories. Okay. I'm wrapping it in use callback because we don't need to recreate this function again and again. Patch error, console error is this, and finally, perfect. And this is going to be run once. Okay, so there's no dependency array here, which means that uh, if something changes, we don't need to recall this. Well, ideally we could every time query changes, but don't need to right now. Okay, this is more or less for our first load. So on the first load, we want to ensure that there's an immediate initial load. Okay, and it goes and fetches all the memories. Afterwards we'll debounce every thing. What is debounce? uh, Axios still good? I think yes. 1.14.1 has been released, if I remember, or it went down to 1.14.0. Uh, I'm not using it just to not have another dependency. Already have a lot here, if I remember. Yeah, like the bare minimum. And fetch will do everything that we need to. So I guess it's fine. Hmm. Is first render dot current? Yes, this, yes, yep. Fetch memories and return. Perfect. Okay. What would be the return type of this? You can, like, it is going to be void, so you can just add that. Good to add, not really needed, but just good to add. If debounce ref dot current clear timeout, so this is us ensuring that there is no previous timeouts. And debounce ref dot current, we are going to set the timeout void yes and 500 milliseconds. Cool. And the return cleanup function, if there is something currently debounce, clear it. And this depends on search and fetch memories. Awesome, 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 awesome. uh, we need one more. Const display memories. Memories equals, we'll memoize. uh, Another question for folks, if you had joined my previous session, then you would know, like in last GHW I had done this. uh, Callback and memo. So use memo. What's the difference between use callback and use memo? If this is 0, return all the memories. That is good. Else just return memories dot filter memory. Yep, this is good. And memories and active tags every time that changes. Okay. So this is also one of the better ones that we have had. Next, what else? Uh, let's create some functions as well. So this would be kind of one-stop shop for everything. Handle tag click. So this set active tags previous dot includes the tag, then filter it out else. Okay, perfect. So pure functions. Uh, function function open create. Maybe I should name it open create form. Okay, better naming. Uh, Open create form. What should this do? Set editing memory to null and set form open to true. Open edit form. It takes a memory. Set editing memory to memory as an input and set form open to true. Uh, a close form, of course, it will set the form open to false and set editing memory to null. Okay, every time user clicks on closing the form. What else? Async function handle save. That will take the data. It will omit out the memory. From the memory, it will omit out ID created at and updated at, which technically wouldn't be given, but still. If editing memory, in that case, await update memory, and we need to provide it the ID and the data. Uh, Else, the other code path is that the user is going to create memory with the given data. And finally, we will call the fetch memories. And do we need to call the close form? Yeah, sure. After save has been done, the form will be closed. Okay, another function, handle delete, to delete something. And in this case, we will just await the delete memory. The ID would be given. We will set memories. If you delete a memory of something that was filtered out, then you need to reset the filter. Okay, of course. Finally, one more is filtered. Search dot trim dot length, it should be greater than 0, or active tags dot length greater than 0. Const count label equals to use ah, too much. I can just do use memo around it, and we can say that is filtered is filtered and display memories dot length not equal to memories dot length. Then in that case, display memories of memories. Else, and finally closes on this. What is ah, filtered? Filtered. Okay, finally, we can return everything from here. We can return display memories, loading, search, set search, active tags, set active tags. Then open, create. What else was there? Form, open, editing memory, uh, count, label, handle. I think yes, everything that we have written has been kind of exported from here. Okay, so that is really, I do that a lot. Okay, fair enough. Okay, that's Max Verstappen. uh, what am I missing? Handle tag click, open edit form, open create form. Let me put these together. Create form, edit form, uh, close form, save, delete, counting, count, label, filtered is filtered. Did I export is filtered? No. Okay, is filtered, count, label, editing memory, form, open, set active tags, active search, loading, display memories. Okay, I think this should be good enough. Perfect. Okay, so that is all our hook. So going back, this is for fetching the memories. In the use effect, we are calling it once, uh, but after that we'll debounce. So user types like let's say A, B, C, we will wait for 500 milliseconds before we set the send it out to search. Display memories is which memories to display, like all the memories to display technically. But if you filter out by a tag, you say I only want to see, let's say, React memories, it will do that filtering on the UI itself. Okay. uh, Creating a form, it will create open a modal where you will have a form. Open edit form will open a new modal where you can edit an existing form. Close form, as the name says, it will close the form. Handle save will save it. Handle delete will delete a particular memory. Is filtered out, it's basically checking if there are any filters applied right now. And this is more of a visual thing where it will say you have, like if you filter out, you had total 10 memories and you click on a filter, React filter. Okay, then you will see 5, so it will say 5 of showing 5 of 10 kind of. Okay, 5 of 10 memories. If there's only one, then it won't be plural, it would be singular, so showing 1 of 10 memory. One memory or out of 10, something like that. Or there's only one memory, sorry. So then it will showing 1 of 1 memory. Okay, cool. So I guess that is everything in terms of the major two files uh, that are more or less handwritten. Everything else can be copy pasted. So let's start from that. uh, Memory card, copy pasting everything. So we'll have our memory, of course, all the active tags on edit, on delete, on tags click. Format relative will basically show how long ago was that memory saved. It's like it was 20 minutes ago, 30 minutes ago, 1 hour ago, 5 hours ago, 2 days ago, something like that. Format full will show the whole date time together. And then we have uh, now, every memory card will have a copy button as well. So on click, it will copy whatever memory it has, uh, and this is just the visual UI. Uh, all the CSS has been in index.css. Okay, then let's go to the next one, memory form. Memory form. There we go. I'm not going over React or kind of skimming over it, specifically because not really the crux of everything that we're building. And also, I'm going to have less time. So props memory form will take a memory on save and on close functions. What happens on save, on close? If the user presses escape button, then we want to close the form. Okay. Uh, the form could be the edit form or the create new form. It will allow users to type the title, the content, the tags. There will be a cancel button, and there are some placeholders around. Then memory list. Let's go for that. This is where all the memories will be shown slash listed. So multiple cards will be shown here. Okay, so that is why it imports memory card. So on the whole page, there will be card, like 5 or 6 cards, kind of. So that's our memory card. And finally, we'll have the search bar where the user can search for something. And that's it. So now if I go back, uh, I need to go to app.tsx and I need to fill out the app.tsx as well. Okay. So in app.tsx, everything that we have exported will be imported here. So that means our use memories hook will be imported here, search bar, our memory list, our memory form. And inside our memory form, we are already using the memory card. So I guess that's all of it. So let's kind of I guess that's it. Perfect. There we go. That is our UI up and ready. Okay. Uh, Currently, it says there are no memories, which is weird. It should have at least the two memories that were here. So what am I missing? I'm missing out on wheat config. In my wheat config, I need to tell it. Also, I don't need this readme. Stupid. And I can call this as mini memory MCP. Mini memory MCP UI. In my wheat config, uh, everything else is fine. And the server, but in here, we need to say that the server will be running on server, as in the UI currently is going to run on 5173. And we need to proxy over for the server to come from 5172. Okay, so now let me stop and restart it. And there we go. Perfect. Done. Okay. So proxy over basically tells it change origin is not required. Or better to have it true, possibly. So change origin says that, oh, it's coming from some other URL. Uh, Fine, good to add it. But we are saying that all the API requests are going to come from localhost 5172. So that is it. Now, if I click on this, it shows one of two memories. Uh, we can copy a memory. We can click on edit to read through the memory. Okay, this is the full memory. Every tags that it has, we can create a new memory, short descriptive title, what's the content, what the tags are. uh, we can delete a memory, click on delete, it asks you for confirmation. Are you sure you want to delete this or no? I don't want to delete it, but I can delete this one, and now it shows one memory. Okay, now every filter will basically be that clear all clears all the filters, and yeah, that's it. Okay, so now let's go back to our copilot and tell it update the mini memory MCP project with latest details. Okay, so I've asked it to basically update based on the latest details. So previously, it had said that in wheat in UI it was currently minimal. Okay, let's see now if it can actually update it to the latest that we have. Okay, let's see. Okay, not that great. I should have given it slightly more context. I have updated the UI project completely. Note that down in I don't know what did it update. Interestingly, okay, done. Refresh. Let's see. MCP standard IO. UI is this much. Perfect. Typed fetch FNS. State management MGMT, as you can see, the bound search, tag filter, CRUD operations. So took all of our functions and said, yeah, it's a CRUD operation. Some components, wires header, plus list, plus Moodle form. Awesome. So that is our memory. Let's see if it's still within 100 words or not. 87. Perfect. Awesome there. And that's our MCP server saving all the memories. So now every time it starts up, it can, uh, specific instructions will make it ensure that it reads the latest memories and then works on relevant memories. And you don't have to tell it to scan your repository again and again. So that's the UI bit. Let me push this and then we'll do the final one where I said we need to hook it up for the HTTP. What did we do? We added UI components for mini memory MCP. Okay, there we go. The UI should be up and running as like should be working as well for you all as. And okay, cool. So any questions before we go to the last bit, which is like literally the last bit for everything? Okay, seems like no questions. Everything is fine. Okay. So the last bit that we need to do is basically go over here and we need to I guess this is not a question, but okay, that is good. Okay, so the last thing that we need to do is basically we need to improve the index.ts for the else bit where we want to connect it as a streamable HTTP transport. Okay, let's see. We have initialize express. We are using cores. We are uh, using express.json. That is fine. We are now going to use the memories API slash memories memory router. Let's do the next bit. Const transport echo is this is going to be of type record of string comma streamable HTTP server transport and starts empty. So this is currently imported from where did it go? Yeah, model context protocol slash server slash streamable HTTP SDK slash this. So basically from this one. Again, I don't know why in their documentation Well, actually, we don't really need that, right? We saw that yesterday. We were able to do everything without the .js. I don't know why they explicitly have added .js in all of it, but I guess this should do the trick. Uh, 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 an express process. Okay, cool. So it's coming from the model context library, model context protocol library. Uh, okay. So what are we going to do? So we are going to create like a way for each MCP client to get its own server instance. Okay. And we'll identify it based on some session ID header. So example, uh, Copilot is connected to our MCP using like URL. Claude is connected to our MCP using a URL. Claude makes a request, Copilot makes a request. The response needs to identify which one came from Claude and send the response to Claude. Which one came from Copilot, send the response to Copilot. So it needs to identify it somehow, okay, where it came from and where to give, whom to give the response back. So that is what we are currently doing. So more like transports, multiple ones. So we will do app dot post and we will say like on slash mcp. Let's do const session id equals mcp session id. Okay, so every time an mcp connects via this http, it is going to send a post request for this session id. Okay, so now after this, uh, so if the session ID is present already, in that case, we will use that session ID or we will generate a new session ID. Okay. So if a session ID is present, which will be a random UUID, then that means that the request is coming from this particular client. So, okay, does that make sense what I'm trying to say? So we need to uniquely identify where the request is coming from so that the response can be sent back to that asking server. So we will look for this header, okay, MCP session ID. If this header is already present, then that means I already know about the client and I need to send the response back to that client. If this session ID, MCP session ID header is not present in the request, then it means it's a new client. So I will give them a new UUID and will send the response back for that, like to that UUID. So if session ID and in the transports, there is a session ID, not a ID. If this is the case, so basically it already is present, then in that case we will do await from transports. This is good, and then request dot body and return. So if a session ID is already present, then in my transports object, I will already know about it. So all the request should be routed to that one. If it is not present, then there is something called as is initialize request, which is coming from again model context protocol request.body. Now in this case I will say that you need to initialize it. So const transport equals new streamable HTTP server transport, and we need to pass some stuff in this. We'll say a session ID generator is going to be a very random UUID from the crypto library. And on session initialized session ID, we will add it, like we can actually do, yes, this, and also add it in transports for SID for this one. Perfect. Okay, any questions like what I did here? All I did, like if the session ID is not present, then it means it's a new client connecting to our service. If a new client is connecting to our service, then step one, we'll give them a randomly generated UUID, and now that is a new session initialized. So we'll save the details of that client in our object locally. So this is all local, okay? So every time you shut down and restart, a new session ID will be given to your AI agents. Okay, we are not remembering it for eternity. Okay, cool. Next is transport dot on close. Okay, whenever this happens, in that case, we will say this and delete from. Perfect. So whenever the session closes, we will log what session closed and delete that session ID from our lookup table. Okay, so we can call that transport as kind of a lookup table of what is already present, what isn't present. And now, yeah, this ends here. So now each session will get its own MCP server instance with memory tools, register, and everything. Okay, so const MCP server equals to this. Did I call it mini memory here? Huh. So the name in mini memory MCP, because that's how I saved it, right? That's why you should have constants defined up on the top of the file. Uh, Register memory tools for this MCP server, await MCP server.connect transport, and this is going to handle request, and we can just do a return. Like nothing much to do here. Okay, and finally, I guess outside of this, what we want to do, 400 if there's a invalid request. Okay, actually I'm going to make it as JSON RPC 2.0 errors is going to have some sort of code and a message. 32,600, where did that come from? I think this could be any number. Guess the most popular one that Claude has is 3200. uh, yes, so that is not a standard error code, it is more like a user defined custom code. So well, it could be anything, so I will go for 32,000. I don't think this is a 32,000 uh, HTTP error code. minus 32,000 HTTP error code. Yeah, something like this. Some weird error code. I don't really know where it came from, but you could have whatever. Uh, why not just send back 400 again? I don't know. Um, okay, cool. So that is a restart status, and we're still inside the else, right? That else ends, yep, right at the end. Okay, and now the if condition that is done. Which one is this? Slash MCP. Okay, so now we are coming out of slash MCP. Okay, so that was our first post request, and now we'll go for slash, like a get request, a delete request. These are two more things that we need to basically add. Okay, session ID, yes. If I normally go for the not first, so that we can do an early return. In this case, yeah, blah blah blah, return else basically await transports of session ID dot handle request. Perfect. And one last one would be app dot delete MCP. Uh, Try to get the headers. If they are not present, send an error code. If present, in that case, just call the handle request. And that is the delete as well. Other than this, I guess everything is done. Okay, I guess this is it. Now, how would you add this one? So let's try this out. So step one, we will go to our package JSON. To run the MCP, we'll have to do this start one. Okay. So npm run start, not norm run, npm run start. They should start our server. Oh, it is already running. Oh yeah, let me restart this then. 5172. Uh, let's go here. I need to remove from Claude. Claude MCP remove mini memory MCP. And mini memory. Okay, perfect. So there is no MCP. Now we need to add this. Okay, how do we add the uh, transport one? Okay, so simple is we do Claude MCP add the name of it. So mini dash memory dash MCP. We define the transport. So transport is going to be HTTP, and then we give the URL. So HTTP colon / local host colon 5172, and all our requests are going to slash MCP if I'm not wrong. Hmm, yes, invalid right now, but this is where all the requests are going to go. So I can add this, and now let me run Claude just like that, and let me do slash MCP, and there is the mini memory MCP. Okay, As you can see, it is currently connected. It has 6 tools. It also has this authentication and clear authentication. So that is where the session ID and like new session ID, old session ID uh, happens. Okay, it's kind of connected to that. I can ask it to reconnect. So it reconnected successfully. Now let me ask it, fetch all memories. Okay, fetch all saved memories in mini memory. Let's see if this works out. Well, it is calling the tool correctly. Uh, and it also remember, like, this is the description that we had given. Yes, please do this. Here is a single saved memory and it got the memory back. That is the only memory stored so far. There's a title, ID, tags, and blah, blah, blah. Okay, so now let me ask it, uh, read through the whole UI and server, update the mini memory MCP project details, and then create or then update the readme with guide on what the project is about, how to run stdio and http connections, how to use it, and how to use it. Okay, let's see. So that is the final instruction that I have given it. It's going to explore, run everything, create the README, and then I will do a push. Meanwhile, any questions, anyone? You've seen how to connect it via HTTP transport, via STDIO. My suggestion would be STDIO for everything, because when you do HTTP, you have to keep the server running. But if you do standard IO, in that case, you just point it to the correct file and it takes care of the rest. Okay. We saw how to add the MCP to, like, let's say Claude, and how to add it to your Copilot as well. Okay. In this, so in here, you just need to change it to HTTP. I think that's the other type. Yeah, type, I think it's HTTP or it needs to be removed, something like that. And this will point to the local host. Okay. So it's going to, oops, yes, the node server? No, I guess apparently it's not required when it's a node server. Oops, error writing to readme.md. Why? Maybe it's searching for the wrong readme.md. Okay, so this one should have been updated. Let's see. Perfect. Yeah. And all I need to do is just do a quick word count, because it's pretty exciting. Oh, 90 words. It's still able to, you're still able to give every detail within 90 words. Okay, pretty cool. And yes, please. Let's see. Both done. Hopefully it is correct. Lightweight, blah blah blah. What it does, fine. Project structure, fine. Prerequisites, install. REST API, running the server in HTTP mode, standard IO mode, running the UI, connecting the MCP. Uh, Cloud desktop config.json. There's a thing like that? I didn't know. Via CLI, this is what we did. Uh, for GitHub Copilot, yes, and streamable, fine, available REST APIs, example search, filter tag, syntax, memory schema. Perfect, awesome. That is the end of it. Let me do a let me push all of this. Uh, any questions, anyone? Sorry, I'm asking again before we end the session. Hopefully it makes sense of what we have built, how to use it. We have seen it in action. You can build any MCP you want, whether MCP, uh, details MCP. Someone had the idea of doing one for the university to get the timetable or something, MCP for that. Yeah, any number of things. Um, we saw the sessions as well, so that if the request is coming from two different AI tools, how to route the response to correct one. Yeah, I guess that's it's it. We added HTTP transport for MCP and updated README. Git push. Awesome. So one last time, here you go. Or everything that we have built so far, it's here. All the details on how to run it is here. Mini memory MCP, uh, 14 commits. We have been able to finish it off, and it works. It can be used every day, day to day. You can use it. Uh, Improve on it. I have at least two pull requests now. Okay, I will uh, review and add both of these. Thank you so much for all the pull requests. I think this can be added like right now. I don't like this. I like it the other way. No, like not anyone. I don't like GitHub doing that. uh, and this one, did you update it with that agents MD? Oh, yes. Perfect. Awesome. Thank you so much for this as well. And I can literally merge this as well. Awesome. Thank you both for these two pull requests. Really helpful, genuinely. Uh, Especially with the all the links. Actually, it will be helpful even to me after this. Uh, Agents.md. Awesome. Didn't know about that. That was really new to me. So thanks. And this is helpful to others. Perfect. Okay, and one final thing, as always, please provide feedback. Any sort of constructive criticism is really appreciated. Things you liked, things you didn't like, things I can improve for my next sessions whenever I do the next one. So this was the persistent memories MCP server part 3. Give your feedback, provide content. I'm not giving star ratings to myself yet. uh, and I hope to see you in the next one. If any questions, anyone, last time? Ah, you are absolutely welcome. This is what I love to do. Uh, and this was also helpful. Like I learned a lot of new things from you all. So thanks for that. If no further questions, thank you so much once again. And uh, enjoy the whole of Global Hack Week. We'll have some awesome streams uh, even after this. So, if you want to take a break, we'll have Bob Ross painting possibly today. And then There's going to be introduction to AWS, Gemini API for robotics part two. It's like so many awesome sessions. So definitely join all of those. And I will see you in the next one. Cheers. Bye bye.